Hey, good morning. It's me, Mr. Truman, back for another lesson in geometry. And today we are going over chords. In our last lesson, we went over something called tangent lines, which were lines that intersected a circle at exactly one point. And today we're going to be looking at something called a chord, which is a segment, not a line, a segment that intersects a circle at 2 points. So the first thing we want to look at on a chord is, or just try to look at a diagram and see what a chord is. Segment EG and segment AC in this diagram, for example, would be a chord. They touch the circle, intersect the circle at exactly 2 points. Now, if that chord happens to go through the center of a circle, it stops being so much a chord and we start referring to it as a diameter. So if you look over here, A to F is what we call a diameter. It's a chord, yes, it intersects the circle 2 times, but it goes through the center, and that makes it something called a diameter. So we're going to be looking at that today, and we're going to be looking at 3 main rules, and there are a few more, but I've kind of summarized this because these videos, I try to keep them within a certain time limit, and if I was to go over every single part of every single theorem, I just wouldn't be able to get this done. So this is a quick summary. So the first thing I want to look at is if 2 chords are congruent. So if we have 2 chords on a circle, and they are the same length, then the angles they form and the arcs they form are going to be of the same exact measure as well. So for example, in this diagram, I have EG and I have AC. If those 2 are the exact same length, the arc EG will have to be the same as the arc AC and vice versa. The next one is if 2 chords are equidistant from the center. So if you imagine, like in this diagram, here's the center. If the distance from this center to this chord is the same as this one, then the chords have to be the same exact length. They have to be congruent. So, and then our last one is if a diameter is perpendicular to a chord. So if we have a diameter and it's perpendicular to the chord, then the chord is being bisected. So it splits it into 2 equal halves, congruent halves. All right, with all that being said, let's look at our first example. And most of these are really straightforward, except with all of them, I really want everyone to be able to, you should try to get my students to make sure that they can justify why they answer. So on our first one, for example, we have, if the measure of arc AC is 100 degrees, so if I have 100 degrees right here, what is the measure of arc EG? Well, I'll tell you what, it's 100. And here's why I know it's 100. If I look at the drawing carefully, I see that the distance from D to F is the same as D to B. So these 2 chords are equidistant from the center. Okay, so that tells me that they're equidistant from the center, which means that this chord is the same as this chord, which means their arcs are congruent. So this is 100 degrees because the other one's 100 degrees, and it comes down to being equidistant from the center. And when they're congruent, they have the same arcs. All right, in my next example, I said if AB is 12, so if the distance from A to B is 12, what is the distance from E to G? Well, the answer would be 24, and here's why. Because in this drawing, I see that the center here, we're making a 90 degree with the chord. So from the center to the chord is 90 degrees. That means that the chord is bisected. And because the 2 halves are congruent, if this is 12, then this is 12, which makes 24. And since they are the same distance from the center, that makes this one 24. Oop, I wrote that 100 in the wrong spot. And so the distance from E to G is 24. My last one in this example, I said, if the chord is 100 degrees, what is the measure of ADC? So let's say that we have a chord EG and it's 100 degrees. What is the measure of ADC? So I'm going to have to kind of draw that in, but ADC is an angle. Well, again, if this is 100, that means that the angle or the arc on the outside is 100. And this is called a central angle because it has its vertex at the center of the circle. So if it's at the center of the circle, it's a central angle, And a central angle is equal to the same as an arc. So if the arc is 100, the central angle is 100. And if the central angle is 100, so is the arc. So again, that comes down to being congruency between these two, and then that makes the angles as well. All right, on these next two, you gotta think a little bit. These are more of a visual thing, and they stumped a lot of kids in my class today. They got a little confused. But as we look at it, if you look at the numbers I give you, and look at the things that I've given you, and then try to figure out, we're looking for the distance from A to F. Well, here's what I know. I know that CE is equal to 8, and I know that CD is equal to 6, and I'm trying to figure out the distance from here to here, which on the surface looks like they're completely unrelated items, but they are not, because I'm trying to figure out the distance called a diameter. Well, I may not know the diameter. I don't know why this is here, my bad. I may not know the diameter, but I do know that I have a triangle here, and if I were to figure out the distance from D to E, I would know something called the radius. And what I know about that is that if you have the radius and you double it, you get the diameter. So if I could just figure out the distance from here to here, I could double that number and make it the distance from A to F. So let's start by figuring out that this is a right triangle, and those two sides are called the legs. So 6 squared plus 8 squared is C squared. We'll go to the Pythagorean theorem. So 36 plus 64 is C squared. That's 100. No, the distance from D to E is not 100, it's the square root. So we take the square root and we get 10. And that's where that 10 comes from. I left it up there from last period when I taught this in my classroom. All right, well, that distance from D to E is 10. But if you go from the center of the circle to the edge, that's called a radius. So the center from here to here also has to be 10. Just like from E to A has to be 10, which would technically mean this one right here is 2, and the distance from A to F is now 20. It's the entire distance across, 10 and 10. All right, we have one more example to wrap up this video, and it's looking at this last one here, example 5. I said if the measure of AD is 42 degrees. So I know that this is 42 degrees for this arc. What is the measure of BF? Well, some people are like, whoa, that's completely on the other side. How would I know? There's one significant thing about this drawing that helps you figure it all out. And that's the fact that this is a diameter that intersects a chord, and it does it at 90 degrees. Because it intersects at 90 degrees, that means it divides it evenly, it bisects it. So if this is 42, so is this. And that's significant for a second reason, because of this being a diameter is half, it's dividing the circle into 2 halves. So that means that the top half and the bottom half both have to be 180 degrees, because 180 plus 180 makes 360. So if this is 42, and I know that all the way around is 180, this would have to be 138, because together they have to add up to 180. So the answer is 138. And that would also make this one 138. So this is your basic rundown of what a chord is and some just basic problems about chords. Hope this helps. Thank you.